All right. In Lab 6, you are going to watch a puck. You're going to watch this puck go up an incline, and it's going to stop. The first video clip you have allows you to measure the initial speed that it has. Remember, at the bottom of the ramp, it'll have kinetic energy, and as it goes up, it'll lose kinetic energy, and that will turn into potential energy. Since this is a magnetic levitation device, and there's not much friction, we can assume that all that kinetic energy it has is equal to the potential energy at the top. And that's what you're going to use to predict the height above the ground that it rises. Not the length of the track, but the height above the ground. So to do that, you're going to have to figure out the speed of it. And we're going to assume that the speed of it is constant on the flat part. So you guys will advance this to a point where it's not touching the hand. And you will turn on your time, zero it, turn on your ruler, and I would just measure how far it goes from the 0 mark, and I would just step it forward until it's almost ready to go up the ramp. And you can figure out how far it traveled during this period of time. So you know that it's been moving for 0.0375 seconds, and then you can just literally measure with the ruler how far it traveled. Now you can find its speed. Then you use conservation of momentum to predict the height of it. And you're going to show all your work and everything. You can upload it as an image or whatever. Then finally, you're going to measure how high it really does go. And remember that when you do that, you want to make sure that you measure its height, actually using the right ruler, the vertical ruler, and you want the 0 mark to be level with the flat part of the track. So you're going to want to make sure that that 0 is the flat part of the track. So there's going to be a little error there. And then you'll just fast forward it. The next video has it going all the way up, and you'll measure how high the center of mass of that puck goes.